10,000 years ago, the people living in Britain looked nothing like they do today. Blue eyes, dark curly hair, and skin far darker than any modern English person. This isn't a theory, it's what the DNA told us. Scientists at the Natural History Museum in London reconstructed his appearance in 2018 from a skeleton found in an English cave. And if that surprised you, it's only the beginning. Because the reason humans have different skin colors in the first place isn't the one you were taught in school. Dark skin, to protect from sunburn. Light skin, because there's less sun up north and the skin just faded. Sounds so obvious you'd never bother to question it. But that explanation is a bit like saying your heart exists to make a beating sound. Technically true, basically wrong. The real reason isn't obvious at all. And to get to it, we need to start with one fact most people don't know. Every human on the planet has the same number of cells that produce skin pigment. A person from Nigeria and a person from Norway, the exact same count per square inch. The only difference is how hard those cells are working. And behind that difference is a story that stretches back 1.5 million years. That's when our ancestors started losing their body hair. The hair follicles never disappeared. We still have as many as chimpanzees do. Ours just stopped producing real hair. Under their fur, chimps have light skin, and our ancestors were probably light-skinned too, as long as the hair was protecting them. But once it was gone, bare skin was left facing the equatorial sun with nothing in between. Now, here's where you'd expect the obvious answer. Ultraviolet light damages DNA, causes cancer, so the skin darkened for protection, right? An anthropologist named Nina Jablonski at Penn State noticed a hole in that logic. Skin cancer usually shows up after 40 or 50. By that age, our ancestors had already had their children, and evolution, bluntly, doesn't care what happens to you after you've reproduced. Cancer is a weak explanation. The selection pressure just isn't strong enough. So what was it? In 1978, two biochemists from Minnesota, Branda and Eaton, ran a simple lab experiment. They took human blood plasma, put it under a lamp simulating strong sunlight. Within 1 hour, nearly half of one specific vitamin in the blood, folic acid, had broken down, just fell apart under ultraviolet light. And here's why that matters. Without folic acid, a pregnant woman's baby can develop with a malformed spine, serious damage that's incompatible with a normal life. And in men, low folate disrupts sperm production. The sun wasn't just burning our ancestors' skin, it was attacking the one thing that mattered most, their ability to have healthy children. That's why skin darkened. A dark pigment called melanin intercepts ultraviolet light before it reaches the blood vessels beneath the skin, where blood-carrying folic acid flows. Skin didn't darken so you'd be comfortable at the beach. It darkened so your ancestors could have living children. Jablonski proved it by pulling NASA's global ultraviolet data and mapping it against the skin color of indigenous populations. The match was almost perfect. More ultraviolet, darker skin. Less ultraviolet, lighter skin. No exceptions. Well, almost no exceptions. We'll get to that one. All right. Dark skin protects folate. So why would anyone's skin ever get lighter? Why not just stay dark? Because dark skin has a cost, vitamin D. Vitamin D is made in the skin using the same ultraviolet light that destroys folate. Dark pigment blocks UV and blocks vitamin D production right along with it. In Africa, that's no problem, plenty of sun. But when humans migrated north, they walked into a trap. Short winter days, low sun, clouds. Almost no UV, and dark skin won't let in even the little that's there. Without vitamin D, bones stop hardening. They stay soft, almost like cartilage. In children, legs bend and bow under body weight. In adults, bones break under ordinary strain. In women, the pelvis warps, and childbirth becomes fatal for both mother and baby. Evolution did the math fast. Those whose pigment cells worked a little less aggressively had more surviving children. And within a few thousand years, not millions, thousands, the skin of entire populations got lighter. And it happened at a speed that's staggering by evolutionary standards. In 2005, geneticists found one specific mutation, a swap of just one amino acid in one gene. That single swap accounts for 25 to 38% of the visible difference in skin color between Europeans and West Africans. One letter in the genetic code and a quarter of the whole picture. It appeared roughly 29,000 years ago, and it spread so fast that geneticists call it one of the most powerful signals of natural selection in the entire human genome. The body really wanted to get lighter. But Europeans didn't lighten up on their own. Ancient DNA showed that the lightening happened in two waves. The first, about 8,500 years ago, when farmers migrated from what is now Turkey, already carrying the light mutation. The second, around 5,000 years ago, when steppe herders arrived with yet another one. Modern Europeans are a mix of three groups: dark-skinned hunters like Cheddar Man, lightning farmers, and steppe nomads. 3 ingredients, 1 result. And Cheddar Man was one of the first group. He didn't live to see waves 2 and 3. In East Asia, skin lightened separately, through a different mutation, in a different gene, completely independent from Europe. Same problem. Let in more ultraviolet for vitamin D, and a totally different solution. Evolution doesn't copy homework. It writes from scratch every time. And geneticist Sarah Tishkoff at the University of Pennsylvania showed in 2017 that the range of skin color within Africa itself, from the very light sand people to the extremely dark Nilotic herders, is wider than between any two continents. Some of the light gene variants in Ethiopians aren't local evolution at all. They're a reverse migration. People left Africa, got lighter in the Middle East, and some came back, bringing light gene variants with them. Remember when I said almost no exceptions? Here it is. The Inuit, living in the Arctic, no sun for months. By the logic of less UV equals lighter skin, they should be paler than Scandinavians, but they're noticeably darker. 2 reasons. First, they arrived in the Arctic only about 5,000 years ago. Not enough time to change much. Second, they found a different solution. Instead of changing their skin, they changed their diet. Seal liver, Arctic char, walrus blubber, all of it packed with vitamin D. Why rewrite your genetics when you can just eat right? But that solution turned out to be fragile. When the Inuit switched to Western food, pasta, bread, sugar, cases of that same soft bone disease started showing up in Nunavut, Canada. You can break a diet in 1 generation. You can't break a genetic adaptation. And finally, 2 facts that change how you think about the word melanin. Look at your palms. They're lighter than the back of your hand. On every person with every skin color. There are almost no working pigment cells there. Instead, your palms are protected by a thick layer of hardened skin, like a built-in glove. Evolution didn't bother spending pigment where it wasn't needed. And inside your brain, in a region literally called the substantia nigra, which means black substance, sits a different type of melanin, neuromelanin. It shields the neurons that produce dopamine from toxic iron. In people with Parkinson's disease, there's roughly half the normal amount. The same molecule that determines your skin color in a different location keeps your brain running. Melanin is far more than just color. Here's the whole story. 1.5 million years ago, our ancestors lost their fur and darkened to keep folic acid in their blood from breaking down so their children would be born healthy. Then some of them moved north and got lighter, so their skin would let in enough ultraviolet for vitamin D and their bones wouldn't soften. They lightened 2 different ways, one path in Europe, another in Asia. Some of the lighter ones migrated back to Africa and mixed with darker populations. And those who moved to the Arctic didn't bother changing their skin at all. They changed their food instead. Skin color isn't a label or a category. It's a setting. Your body's answer to one question. How much ultraviolet is there, right here, where I live? Cheddar Man was a dark-skinned, blue-eyed Brit 10,000 years ago. If evolution teaches us anything, 10,000 years from now, people will look different again. We're not the final product. We're a rough draft.